Hello everyone, welcome back to Tech Outsourcing Insights. Today, we are diving into a crucial topic for anyone involved in software development: how to choose the right technology stack for your next project. Whether you are a CEO, a startup founder, a solutions architect, or any key technology decision maker in an organization, the technology stack you choose can make or break your project. So let's break down the steps to make sure you get it right. Before we dive deeper, let's quickly break down what people mean when they mention the word tech stack in the context of modern day applications. So, a tech stack is basically the set of tools, programming languages, and frameworks that are used to build and run an app. The major components of a tech stack are the frontend, the backend, the database server, and all the infrastructure components required to deploy and run them. Frontend is usually a web or mobile app that the users see and use to interact with the application. The backend is where all the behind the scenes processing happens and is generally deployed in a cloud platform. The backend server exposes APIs for the frontend to communicate with it. The database server stores all the data and communicates with your backend server. The frontend uses HTTP requests in most cases to communicate with the APIs exposed by the backend server. Now, let's look at the important steps involved in the process of choosing the right tech stack for a project. First up, you need to fully understand your project requirements. This is where you define the scope. What exactly is your software supposed to do? Understand who is going to use the software and what are their pain points. You should also have a fair picture of performance needs for your project, even if you are just beginning. What kind of load are you expecting? Does the software need to scale substantially in the near future? And of course, security. How sensitive is the data you're handling? Make sure your stack can meet necessary security standards. These are some key considerations you need to focus on in the first step. Now that you know what your project needs, it's time to look at your technology options. We are mainly going to look at the options available for frontend, backend, and database in this session. For each of these areas, there are multiple amazing technology frameworks available today, each with its own pros and cons. In this session, we do not intend to do a deep dive into the strengths, weaknesses, and use cases for each framework because that will need one entire session for each one of them. Rather, we'll give you some key considerations to look at when deciding the right framework at each layer. Let's look at the front-end technologies first. For the front-end, one of the first things you need to decide is on what platforms are you intending to launch the app. Are you launching on both Android and iOS mobile platforms? Or is it only going to be on the web? Or do you need a desktop version of the app as well? If you are mainly targeting mobile platforms, then cross-platform front-end frameworks like React Native, Flutter, or Xamarin are good choices. If it's only going to be on the web, then React.js or Next would be ideal choices. If you want to launch your app on all platforms including Android, iOS, web, and all major desktop OS like Mac, Windows, and Linux, then Flutter is the clear winner here. If you use Flutter, from a single codebase, you can export your app to all these available platforms, that too with almost native level performance in each of them. If you really need to develop a native app for Android or iOS due to some very specific requirements like GPU intensive games or advanced hardware accelerations, or to implement features like augmented reality or virtual reality, then of course you have native app frameworks like Kotlin for Android and Swift for iOS. Here is a summary of major strengths and platforms supported by popular front-end stacks. Now let's move on to the backend technologies. While choosing the backend, some of the key points you need to consider are real-time data processing, community support, resource availability, performance, security, fast development, concurrency, and scalability. If security and scalability are your major priorities, then Java Spring Boot is a good option. Node.js is a good choice if real-time data processing is a major consideration for you. If concurrency and performance matter the most, then Golang is a clear choice. Laravel is good for fast development and resource availability. Python Django, on the other hand, is a good choice for the backend if security and fast development are your priorities. So we briefly went through some of the most popular front-end and back-end technologies available today. Now let's talk about databases. The database itself is a huge topic, but let's look at some of the popular databases used today. The first thing you need to identify is whether you need a SQL-based relational database or a NoSQL database. Relational databases use structured query language or SQL for managing and querying data. Tables in a relational database are organized in a structured format and are related to each other through primary keys and foreign keys. By using these relationships, we can join multiple tables to retrieve complex data sets or generate detailed reports. Let's look at some popular SQL-based databases. MySQL is an open source and widely used database common in the LAMP stack. Postgres is another popular open source database with a lot of advanced features. Oracle database is generally used in large enterprises for its scalability and performance. Microsoft SQL Server is also another enterprise level database, especially in the Windows Server platforms. Then we have SQLite, which is kind of a lightweight embedded database commonly used in mobile apps and browsers. NoSQL databases are designed to handle large volumes of unstructured or semi-structured data. This makes them ideal for scalability and performance in big data and real-time web applications. In a NoSQL database, there are no hard-bound relationships between tables. Some NoSQL databases don't even use tables at all. Instead, they rely on different structures like documents, key value pairs, or graphs to store and access data. Now let's look at some of the popular NoSQL databases. MongoDB is a document-based NoSQL database. It's popular in modern web applications and microservices architectures. Cassandra is a highly scalable distributed NoSQL database developed by Facebook. Redis is an in-memory key value store that is often used for caching, real-time analytics, and message queuing. Elasticsearch is primarily used for full-text search and real-time analytics. Couchbase is a NoSQL database that combines the flexibility of JSON with the performance of key value stores. The next step is to evaluate the skill sets of your existing team. Take a close look at your team's expertise. What skills do they already have? If your team is experienced with a certain stack, it might make sense to stick with that to reduce development time. But what if the best stack requires new skills? Consider the learning curve required. Can your team pick it up quickly or will it slow down the project? You should consider these factors to choose the most suitable stack for your project. And remember, strong community support is a big plus. You must always prefer well-documented technologies with a vibrant community. Alright, now let's talk about constraints because every project has them. First up, budget. Some technologies come with licensing fees or require more expensive hosting. Some of them need more powerful processors and expensive infrastructure. Make sure you are not overextending financially. Then there's your timeline. Certain technologies allow for faster development. So if you are on a tight deadline, you might want to prioritize them. Scalability is another big factor to think about. Are you expecting exponential growth for the product in terms of its user base and features? Will your stack be able to handle the future growth expected? You need to have a clear picture of this. Finally, think about long-term maintenance. How easy will it be to maintain and update the software with the tech stack you have chosen? You should do a clear analysis of all these constraints to arrive at the most suitable tech stack for you. Before you fully commit, it's a great idea to build a proof of concept. A small-scale prototype will help you test the feasibility of your chosen stack. You can run some performance tests to see if the stack meets your expectations under real-world conditions. You can also gather feedback from stakeholders or early users. This validation step can save you a lot of headaches down the road. With all this information in hand, it's time to make the final decision. Weigh the trade-offs carefully. Evaluate all factors that are important to you, like speed, scalability, cost, team expertise, feedback received in the prototype phase, etc. Prioritize your project's most critical needs and align them with the strengths of your technology stack. Once the decision is made, document it thoroughly. Create a technology roadmap that aligns with your project's goals. Also, define best practices for your team to follow when working with the stack. And that's it. By following these steps, you'll be well on your way to choosing the perfect technology stack for your next software project. Reach out to us for any queries on choosing the right tech stack. Please don't forget to like and subscribe. Thanks for watching, and I will see you in the next video.